afternoon, ladies and gentlemen. Welcome back for the second session on defence and security, defence and internal security. My name's John Kedar. Some of you will know me, some of you won't. I spent 30 years in the British military, including running the Geospatial, the Royal Engineers Geospatial part of the military, which was much more about using geospatial information, geospatial technologies to advise commanders in their decision making. And I'll return briefly to that in a minute. I then worked for Ordnance Survey, Britain's national mapping agency, before about a couple of years ago doing my own thing as I sort of get a little bit past it, both in thinking and in hair. And I now give advice to governments in different parts of the world. But in particular here, I work with Geospatial World on a number of their projects, including one I shall talk about in just a second. This is being live broadcast, as most of the sessions are. There are probably people online, which has a real point for us. It means we have to use microphones. We can't walk around, even though this is a small room, unless we've got a microphone in our hand. And if you're asking a question at the end, then again, you'll need a microphone because it just helps those that are online. And I will remind you, and I'm sure the folks at the back will remind us all if we get that wrong. Just like any other session, we'll have the presentations and we'll keep the questions and answers and discussion for the end. And I do ask presenters, including myself, to be very wary of that 10-minute limit, please, so that we have chance for that discussion. We're actually talking about enhancing real-time situational awareness today using Earth observation and geospatial data. And I'm going to introduce that subject in a second, but one of the things that we've been working on in Geospatial World with the United Nations Statistics Division, and indeed others, is a concept called Geospatial Knowledge Infrastructure. And what I want to do is just briefly take you through what that is, because in a sense, geospatial knowledge infrastructure has relevance, doesn't matter what the sector is. But what we're trying to do with the geospatial knowledge infrastructure is move away from just thinking, pushing data out, to the world of knowledge. And it's investigative. We're sort of still working on it. It's a 3-year project. The first year was very much about, what do we even mean? Trying to think that through. This year is very much about engaging with industry sectors and getting their views. And next year is going to be very much about engaging with a much wider digital community for the very reason that actually geospatial is only part of, a very important part of, a much wider integration of data from all sorts of sources to deliver knowledge. And that's where the real relevance applies equally in the military. And some of you will recognize this gentleman. He was a fearsome boss to me. He went on to become the chairman of NATO's military committee and retired from that in June last year. He was an absolute advocate for all things geospatial, geospatial intelligence, and actually he was a geographer by university leaning. But he saw the value of this and lifted geospatial intelligence within the UK community as a result. COVID, we've all lived through, and I think we in this room understand that actually the value of using location to integrate data from many different sources to predict, to observe what was happening before it was reported. And this is a Canadian company called Blue Dot, a lot of medical experts using data from different sources, able to pinpoint Wuhan pneumonia-like something happening back before it became sort of public knowledge. To me, this is just one example of many, and there were others that did it, but it's what we're trying to achieve with geospatial knowledge is move from this idea of just throwing data at decision makers to giving them real understanding to make their decisions with. And of course, in the defence community, that's what we've been trying to do. And in this era, we're all facing, in defence, in wider society, a whole range of, if you like, fourth industrial revolution changes, many of which actually are relevant to geospatial. Real-time sensors, again, grappled with in defence. We've been thinking these things through for a long time, but they're relevant in so many other walks of life too. using the cloud for computing power, a whole range of things shown on here. But the reason we need to start thinking of these is conventional geospatial thinking, as I said earlier, is serving data. Actually, it's knowledge, it's understanding we've really got to get to, and we've got to bring in some of this that's going on. And I think one of the things we're trying to get to with this geospatial knowledge infrastructure, which is a bit of a mouthful of a term, but it's just trying to get the word knowledge across, is in a sense we've got to be much closer to our users. Because if we're trying to deal with knowledge, if you don't understand the problems and the user's needs, how on earth can we be delivering the right solutions, the right understanding that they need? So in a sense, this isn't about pushing something out, it's about what is needed and how do we support that need. And that's the direction we're trying to come from. And you'll all have seen this. It's just lifting that, lifting us up the value chain, if you like, towards knowledge, understanding. And it includes knowledge on demand, that ability for geospatial to be part of the worldwide community that is hungry to use their smartphones to get answers straight away. Well, geospatial data doesn't get interrogated in the questions that they ask. We need to think about how we get what we do closer to those answers, that knowledge on demand. To give you a few slides, there is a vision, and it's putting geospatial at the heart of digital society. There is a definition. I'll just throw it up there very, very briefly. I don't want to prolong this. It's just to let you know it's out there. And rather than goals, there are goals, but I've just put the principles up there, focusing on knowledge. It's about geospatial not being something standalone. It has to be absolutely part of the wider digital infrastructure. Has to be led by users, absolutely. And I mentioned that. To practitioners, we can't do it all, whatever it is. We've got to do the little bits that we can do towards achieving this idea of being able to contribute by giving knowledge, not just data. Agility, decentralized, predictive. Again, predictive. In defense and security, we're quite good. What's the enemy going to do tomorrow? But actually, that needs to permeate through all parts of government. And business intelligence is starting to use geospatial, as we know, to try and predict what customers might do or where they might do things. And in my mind, it's taking geospatial from what is where to why and how. And again, our community has been thinking about this for a long time, and we're trying to build on that. And as with anything like this, we sort of split it into elements. I'm not going to go through each element. All I'm going to say is it's about governments, it is about industry. Much of geospatial thinking is sort of done within either industry or governments. It's absolutely both, and it is the much wider digital ecosystem. So that's all I'm going to say. There's a website and there's a paper and everything out there if you wanted to find out more. But it's a project, it's a journey, and it's with partners. It's not Geospatial World and the United Nations together. There are a whole range of industry partners coming together, contributing to this as well. So that's all I'm going to say in terms of geospatial knowledge infrastructure. It's just to give you a bit of an oversight of it. I was asked to do that. But you can see there is, what we grapple with in defence is absolutely part of, and we're thinking the same things through in defence as perhaps we're now trying to take to a wider ecosystem. So let's move on to, and let's see, I'll come out of slideshow, escape, ready for whoever's up first. Could you, while I talk, if you just get the first one up, which is Leendert's. Yeah, please. So what are we about here? I think this morning, and I wasn't in this morning, but it was quite focused on intelligence, I think. And in a sense, intelligence is absolutely vital to our operational success and our security. But actually, I would suggest that this understanding word, the situational awareness word, covers everything. You can't run logistics operations without situational awareness. You can't run any form of military or security operation without considering all the different aspects. You know, you go into any military headquarters, of course, as many of us know, and it's J1 through to J5 through to J9 or whatever the acronyms are. You know, it's about people right the way through to logistics, about intelligence, it's about operations, and all of those things need a common situational understanding and common situational awareness. So that's what we're about this afternoon, and in particular, how Earth observation and geospatial data and geospatial technologies play their part in delivering that situational awareness. And I go back to what I was just talking about under GKI. You know, essentially, the commanders, the decision makers, cannot be faced with reams and reams of data. They've got to have really simple understanding. And I left the military a few years ago, but I was involved in 2003 when US, Britain invaded Iraq. And I use the word invasion. I'm not saying whether I agree with it or not, but the point was we had a sergeant, 26 years old, working with an armoured brigade. That sergeant was being asked by the brigade commander, Brigadier General, sitting right behind him, okay, do I take my brigade left or right flanking of this particular objective? That's putting enormous responsibility on a 26-year-old person being asked actually to support a brigade commander, Brigadier General in operations, make a decision. The Brigadier General didn't want to see the maps or the data, he just wanted to know left or right. He just wanted that answer. And that's what we are about here. We're about taking all of this information and trying to help give that situational understanding in a way that can be consumed and decisions can be made. With that, I'm going to pass over to our first speaker, first panelist, Mr. Leendert. And Leendert is from the European Maritime Safety Agency. He's the head of department for safety, security and surveillance. And I would just say that for those that don't know EMSA, and I'm sure Leendert will talk more, but it's actually got quite wide safety and security responsibilities in the maritime domain. And they are wide because we often think of the land environment, but the maritime environment, of course, is a far larger part of the world's surface area. Satellite Earth observation, the Copernicus Maritime program comes into this. There are a range of things, and I'm sure Leendert will talk to them. But he's had a lot of experience in the agency. He's been there for a number of years. Leendert, I'd like to give the floor to you.
Okay. Yes, good afternoon. Thank you very much. I think you were doing great. I thought I had an easy job this afternoon. You would continue without me. Would even have been better. Actually, I brought the wrong presentation, also listening to what we discussed this morning. But okay, I will go through the slides that I prepared for you today. You already mentioned, European Maritime Safety Agency is an agency of the European Union. And we are based in Lisbon, Portugal, where we have 270 people working, representing 24 nationalities. Today I want to talk about two capabilities. One is our drone program, and the other thing is what we do with satellite Earth observation information. And then you think 270 people is a lot, but they do a lot of other things. So our team for satellite imagery is around 10 people, and the same for our drone program, also around 10 people. So we are talking here about only a very small fraction of the staff of EMSA working in this domain. Actually, if you have a surveillance capability, you can use it for all type of purposes. And in that sense, of course, we are a maritime safety agency, so I always need a bit of salt water to become active. But once you are over the salt water, you can do many things, and then it does not really matter what type of organization you are representing. Because with the sensor information, you can detect a lot of info that is relevant for everybody that has a task at sea. And that's why, as you can see here, we are supporting actually almost all governmental functions in the maritime domain. So as EMSA, we are an institutional service provider. So more or less we do matchmaking between, on one hand, the user requirements that we gather from member states, but also from our sister agencies in the European Union. And on the other hand, we are mobilizing industry to develop and offer those services, let's say, under our command and control. I always say that we are a bit like the chef in the kitchen. We like to make our own soup, but we are buying the ingredients on the market. And that's a bit what we do also in the field of surveillance. Let's start with our AirPass portfolio. So what we do with drones. We started only in 2017, so roughly 4 to 5 years. We are now developing this capability. And we do it again for multi-purpose maritime surveillance operations, so for any governmental task at sea. Which is maybe a bit more specific is emission monitoring. As you know, we are all very much concerned about the environment. Okay, here we are talking very much about defense and security. But also the environment is a big issue. And there are now more stringent rules for the type of fuel that ships are using at sea. But of course, that is difficult to enforce. It's difficult to check and control. So that's why we have also equipped drones with sniffers that will fly over the ship, over the vessel, taking the measurements of the CO2 and sulfur emissions that they produce. And then this information is being transmitted to the next port of call for further inspection. And it's quite an interesting application as well. Also related to one of our classical tasks is pollution response. So where we also use drones to extend actually the visibility of our pollution response ships. To be able to do it, and the sea is big, the sea is very big, you need also satellite communications to transfer, of course, to steer the drones when they're far out at sea, but also to get the data from the drone to the ground station and from the ground station to the headquarters. We have our own data center, and we're going next year to our second generation data center where we have integrated all that information. So we are working again with different providers. But the look and feel for the end user is the same. So no matter which drone we are using or we are, let's say, providing to a member state, the way the information is being portrayed and being ready for use is always the same for everybody that is using one of our services. At the moment, and every year this changes, we are flying across Europe depending on the request that we got. So at the moment, as you can see here, we are flying in Romania, in France, Spain, Lithuania, Estonia even. And also our oil pollution response vessels are also equipped with drones. So we have a number of drones simultaneously operating in the European Union. And this year, at a certain moment, we even had 11 operations ongoing in parallel. I brought a very small video just to give you an impression of our drones. It's the shortest one that I could find, only 2 minutes. I'm sorry for the people that are listening in because they cannot see it. So let me see if it will work. No sound. Okay, that was it. Just to give you a very quick impression of what our drones are doing. Of course, you can imagine that for confidentiality reasons, no security examples were included, but it gives you a bit of an idea of the drones and how they are being used across Europe. So after this, let's say, exciting part, I will continue with more the satellite observation, as we already discussed in the morning. So at our agency, since 2007, we are offering satellite information services to member states in the European Union. based first on synthetic aperture radar and also on optical. So we have contracts in place for 6 different SAR satellites and 10 different optical satellites that are, of course, owned by various countries. So we are not, doesn't have to be European. So for SAR, we are working with European and Canadian satellites, and for optical, we are mainly working with American and French satellites. As the maritime domain is different than from the land domain. The land domain is mainly about mapping, which is not very time critical because you have an archived image and then you will do kind of analysis on the changes that you see on the image. Of course, in the maritime domain, except for the coastal areas, there is no reference point. The sea is the sea. There's nothing to see on the archived image of the sea. So there we are very much interested in, let's say, moving targets or ships that are moving for whatever reason. So you need to have the information very fast. So in that sense, in our dialogue with the industry, we have pushed them a lot to quickly deliver the information so that it still has a high operational added value. Because the longer you have to wait, the less value a satellite image has in the maritime domain. It's like that you are only informed about traffic jams 2 hours later. But then you are already in the middle of it. So it doesn't make sense. So you need to have the information fast. That's why in our contracts for radar satellites, we have a 20-minute rule, and for optical 30 minutes. What does that time mean? The 20 minutes is from the overpass of the satellite, taking the image, downloading, processing, analyzing the image, and delivering it to the end user. That has to be done in 20 minutes, and we log it. If our contractor, and we have several contractors, does it in 20 minutes plus 1 second, they get 25% less paid. So there's a huge economic incentive for our contractors to really deliver in time. Because we are all focused on operational added value, so our users want to have the information fast. So all our chain and all our contracts are focusing on fast delivery of analyzed information. For optical, they were even less used to deliver it fast, so there we are still lagging a bit behind. But there we, with our latest generation of contracts, we pushed it up to 30 minutes. The 3 main programs that we have based on Earth observation, and here you see roughly the coverage that we had based on the request that we got. So we are running the Clean CNET service, which is very much focused on detecting oil spills, deliberate and accidental discharges. That, of course, is mainly around Europe. Then we support our sister agency Frontex for border control. They are mainly high resolution SAR and optical images, mainly in the Mediterranean Sea, but also in the Baltic. And then we have our Copernicus maritime service, where we support member states all around the world. And you see even in the Indian Ocean, in the Atlantic, in the Caribbean. It has also to do a bit with the, let's say, historical links that there are between EU member states and overseas territories. For example, the French overseas territories, but also the Dutch Caribbean, as we already heard this morning. Roughly in 2020, we had 1,300 satellite images per month ordered and delivered to our end users. And roughly 80-90% is SAR, synthetic aperture radar, and 10 to 20% is optical. I need to hurry up. I will just give you some of the value-added products that we are offering, very much based also on SAR, so vessel detection, feature detection, activity detection, oil spill detection, wind and wave information coming from the satellite image. We are giving oil spill notifications, and we are also correlating the data with vessel information. So we have terrestrial AIS, satellite AIS, long-range identification and tracking, VMS data, which is all merged also as a layer with the satellite image. So what we also do is a lot of correlating the data to find, let's say, non-cooperative ships that are not transmitting any form of positioning. So that also for, depending on the purpose, it's easier to find the vessels of interest. Just quickly, 2 examples. One on search and rescue in the Indian Ocean, which is very difficult to find a ship when there's nobody around. And there with 10 images, we were able to find and track the vessel that was sending out search and rescue signals that we need to help. Pollution monitoring, even in August in Greece, there our services came together where we used SAR, optical and drones to assist in the cleaning up of oil for the Greek authorities. So that is nice that you see that both services strengthen each other. So we always have a kind of toolbox philosophy. So we're not saying one is better than the other. No, certainly in the maritime domain, and I think it was also mentioned this morning, you need all the different data sets that you can to build up a meaningful maritime picture. So it's not one against the other. No, we need everybody on board to do something meaningful, to have a meaningful maritime picture in the maritime domain. This is another one. I will quickly skip and go to artificial intelligence, but this is also one of the themes of the conference, where also for handling the data, and quite often in the past, the issue was a lack of data. Nowadays, it's more that we have too much data, and you need to handle too much data. So for that, you need help of the computer, artificial intelligence, to select and to get out the information that you really need, which you cannot do manually anymore. So there we also started a program. We already prepared our training sets for developing algorithms. So now we start with vessel detection and classification, and then we will develop it further in the time to come. For the vessels, we already have it. We already have 24 different algorithms to detect all type of behavior of ships, and that we are also linking, and now we also bring it to the next stage of artificial intelligence. My last slide, Chairman, don't worry too much. So on the one hand, it is data that we need, and there now we are very much looking in bringing the frequency detection into the civil domain. That is still, I think, an important data set that is missing, and that we would like to have to, let's say, complement the Earth observation and the vessel positioning data that we have. It's all about fulfilling of user needs, so we are in constant dialogue with our users, governments, authorities of states that are using our services. And then, of course, we are also looking at creating more value and now going slowly from detection to prediction, which is one of the next steps that we see as an intellectual challenge to offer even better services in the future. There I stop, Chairman. Thank you very much.
Leendert, thank you very much. And that got me thinking, and I'm sure it got others thinking as well. We'll go on to the next presentation. Keith Barber. We're just getting his presentation up as we speak. Keith is currently serving as the Chief Operating Officer at Tanzle, which provides, as I understand, a platform that helps generate understanding from these multiple big data sets. Keith actually has a military background as well, as an enlisted sailor, transitioned to the civil service, and has over 35 years of experience in working in the military and in security. Keith, floor is yours.
Okay, let me get at the beginning. All right. Hi, thank you, everybody. Wow, you are tall, or I am short. So I think it's the latter. Thanks very much for the introduction. By way of introduction, I spent about 34 years in the U.S. federal government. I was an enlisted sailor. I was a senior executive at the National Geospatial Intelligence Agency. I procured, been a user, been an analyst, I've been a program manager, a budget analyst, have done a myriad of different jobs. And I'm going to show you some elements of, actually in this case we were using Mapbox, but we've also made this a 3D mono web-based tool using a cesium container. So when you're looking at what Tanzle's doing in these slides, what I want you to remember is there's a whole infrastructure that it's impossible to show. It would look like code. That is actually organizing content in multiple different formats and types. We do not care your format or type of data. We more think of data at the binary and family of data's environment rather than there's a geospatial product set, right? We think of data in the binary sense because most of the microservices that are using and culling data today are microservices. So there's a whole debate we can all have over coffee or a beer later on about monoliths and microsystems and, well, I cloud enabled my stack, so now I can do these things. And some of us would argue, well, not really, sort of, kind of, right? And if you can't do the plumbing, the code to actually organize your families and index and do the encryption and be able to stream it to any application, to any API, to any front end, we're kind of losing the meat of what we could do with data. Now, the example that I'm going to walk through, we actually worked with the Seismic Commission in the state of California, and they gave us their problem set. One of their problem sets was after an event, it takes months and months and months to try to figure out the right course of action, what the property loss and damage was, how to tie sensors together, et cetera. And they have structural engineers and emergency response folks, and they have seismologists, and they all work in their own cylinders and struggle to cross talk or communicate with one another. So one of the things people said was, oh, you build a communications platform. Yeah, kinda, but it does more than that. It provides really cognitive, intuitive, means of looking and expressing data. This is the scene that we're all used to looking at. This is Maxar data. This is over the city of San Francisco. So we went and did a chore and said, well, what kind of data sets would I need? Well, if you're a fireman, you might want to look at, well, where are my annual fires? Where are the fire battalions? Where are the boundaries? Where am I responding to? And what are the value of some of the fires? One of the intuitive sets, and it's not in this display, this is actually a live 3D mono environment, like I said, was we started looking at fires that had the larger property damage. When we just looked at just the data, fires, fire stations, pumps, and water lines, what we started to see was a pattern emerging that said, hey, every one of these larger fires happens at the end of a line or in a place where it's distant between the fire stations, which takes longer for pumps and trucks to get there, and the water lines aren't extant. And you start to see patterns emerge where larger fires are further from what the nodes are that are available to fight those fires. And this is data. So the way the platform functions is we have different layers of data that can be turned on and off. You can ingest a data layer. When I ingest a data layer, data pops up on the layer panel, and I can exploit what's in the content. So I can bring it in, look at it, exploit it. The nice thing about this is it's multi-user. So if I'm an emergency response planner, structural engineers can be in the same platform. They can see what I'm doing. I can see what they're doing. I'm still working in my mission, but somebody else can be in there looking too. And to give you an example of what that looks like, the state of California has a strong motion sensor program. These blue dots are literally buildings that are part of that program. So in these buildings are multiple sensor elements that are throughout the building that capture velocity, acceleration, and displacement. Right values that to a seismologist are critical. To anybody else looking at it, maybe not so much, but a structural engineer might care about what the impact of that is to the building. In this display here, what you're seeing is the channels. These are the number of sensors in every one of those buildings. We went a step further. You heard Chris talk a lot about Unity and Unreal. We actually use both of those engines and are building automated paths to put data in those. And what we did in this display was we took a single building, this building. What you're seeing is data that was captured in an earthquake in Napa, but felt by this building in San Francisco. We wanted to go a step further, so we built out the building, and in the live panel, what you'd see is there's a compass at the top of the screen, because orientation of the building is critically important, because these sensors, and I think this one had 18 or 21, are specifically placed where they are in that building. The graph plot across the bottom is the actual capture of the seismic sensors, and the images are simulated. But the idea was somebody could walk out, take images of the damage, put it into the object. So my images get connected to the object. The seismic data gets connected to the object. All of it gets referenced back on the original map, and people can start to interact and see who's doing what and how the clarity goes. When we briefed this out to the Seismic Commission, we were showing our capabilities and what we were building. We lost 30 minutes of our own conversation because the fire chief for Cal OES and the lead structural engineer started redoing their concept of operations because they had just done hurricane relief in Puerto Rico. So they started reevaluating how they would actually walk the footprint, and they were estimating that they could take 7 or 8 months of work and collapse it into about 80 hours. If they had a tool like this, if they had a place where they could just append captured information with base information and put it together with letting folks work in the same space. That's just another view of that. We can project this too in this bottom piece. What you're actually looking at is like a Mac. We put this on the Mac pads now, on iPads. It's a virtual display of Taif, which is in Saudi Arabia, just looking at terrain. But we could do the same levels of information in these pushes to be able to show this now and let planners walk around. So you heard Chris again talk about TAC. I mean, we could do this kind of thing and let planners walk around an objective. Let them plan out an airfield or the officer that was in earlier today, help them plan out Puerto Rico, but do it three-dimensionally. Pull the data, push the data, but it's all about content moving and streaming. We can also do it for space situational awareness. This is personally one of my favorites because I've worked in this space a long time, but to the point where I can see objects in orbit, and this plays in 3D. But I can also have the CAD models of the vehicles themselves. So when I get an error on a vehicle, I can alert to it, and I can go do engineering assessments, and I could do that in a combined way where that's not a big lift and people can see at different levels. I love this from a requirements perspective because I always like to rethink problems on satellites ahead of time. So you could put engineers together and watch operational flavors as you're doing engineering assessments on your next capabilities. That's really my presentation. The real footnote there is that it's not about one single data type. It's about multiple users in a single environment attacking a problem with all the data that you could have, but picking the right data sets and letting the right experts use those data sets. Thank you.
Thank you very much, Keith. That was very insightful. And actually, going back to what I was talking about right at the beginning, geospatial knowledge, it is about bringing data from many different sources together and trying to get the understanding from it. And that was a great case study for that. We're going to move on now. Next up is Cami Brun. Cami is the managing director of a space and EO company, Head Aerospace Technology France. And Cami, before joining Head, she was actually working for Airbus Defence and Space, and I knew her before when she was at Euroconsult, where she spent 8 years or so. That's my last time that I met her. Anyway, Cami, the floor is yours. We look forward to what you have to say.
Good luck. Hello, good afternoon, everyone. So I'm honored to be here. First, I'm very glad that we didn't have any conference since some time, and I'm glad to see some friends and old friends, new friends here today. So I'm Kammy, so I'm managing director. I'm based in France for Head Aerospace. So I think it's important to see who is Head first. So we are actually a young company based in Paris. I joined the company in the beginning to fund this company in 2018. And right now, last 2 years, actually, okay, thanks to COVID, we hire a lot of people locally in different countries. So today we have a global team that we have 14 countries presence. We created a marketplace because today, even yesterday, I talked with some friends, some Colonial Island as well. What is accessibility? There's so many satellites today, but how can you get it? Get the right time, the right place, and easy to get access. So we create a marketplace with access to 45 on-orbit satellites, and we're expecting in 2022, in total 80 satellites. We signed a lot of strategic agreement with different operators that put in place this marketplace. Today, we also operate a network of tier 2 service provider and a network of distributor in the world, around 100 partners in the world today. We also provide ground receiving station because at the end, timing is important. So how fast you can get your data when you need it. So I'll show a use case afterward is that we provide ground receiving station for some of our anchor clients to receive downlink directly in the facilities. So what we offer, a lot of satellites, 45 satellites on orbit already. I have another slide just after, have a quick summary of what we have. Basically, we can say we got you covered. Is that within our 45 satellites, we're very optical, let's say. We have only one radar. Today, the optical satellites, we have 31 satellites, which is offering some meter resolution. We have everything. We have the stereo, we have very wide swath that you can see later. And I can say opticals sometimes is already seen a lot, right? A lot of optical exists. And I believe that we have something maybe different, is that we are also offering night image, real color night image, and also real from space. And today, not so many people using it. It's also the reason why I would like to talk and share and get feedback from you, how you say that it is useful and do some use cases together. Also because there's not so many offer, not people using it a lot, and also because in terms of number of satellites, you need to have sufficient number of satellites in order to have a good revisit and also cover the place that you want to see. So we're in the Netherlands, right? So I will give just a few examples of our reference client today. Netherlands, the surface area is 42,000 kilometers square. So since 2019, we were contracted by the Netherlands Space Office to provide full country coverage of the Netherlands monthly during the crop season. So this is a national data portal that I think people, individual in the Netherlands, can also go to that website to see the coverage of the country. So basically, it's a national portal which consists of aerial, that they update aerial only once per year, and we're providing 5 coverage during actually 4 times summer, 1 time in the winter, of the entire Netherlands coverage. So this comparison is interesting because for this nearly the same budget, actually aerial is very expensive. They can only have 1 day update once per year. Satellites is the place that actually you can have large area covered, more frequent, more updated information on the other country. So we're offering it the Super constellation, which is 4 identical satellites at 50 centimeters of panchromatic. So we've been doing it since 2019 and until 2 more years. So it's what Super look like. So good news is that we have a new second generation of Super satellite, which was launched not so long time ago with 40 centimeters of resolution and 8-band multispectral. So it is defense and intelligence panel, right? So we're also very glad to share is that since this year, since 6 months, we are contracted by CLS, which is a quite reference service provider. We work with them because they are actually working together with HEAD at it. We're providing our 45 optical satellites to CLS for the French Navy project in the next 4 years. So basically, I think the strength is that usually, of course, you have lots of satellites, but at the end, you always don't have the satellite that you need it for tomorrow at the place that you want to task it, and you cannot do it. So at the end, I think the amazing point is that we work with a service provider, and we try to be in place is that you never have what is sufficient. Even you have 10,000 satellites of the world, how you can get it? So it is that's why we work with CLS since this year, and we're also trying to improve our offer as well. So we're in Europe. Somehow it is also important that we're working with ESA since last year, December. So ESA is interested in our satellite because it's new sensor. So we are working with them to provide them, we have night image, video, and also optical hyperspectra. So we're providing satellite image to ESA since last year. I believe that end of this year, ESA will probably publish technical reports on the technical specification of our satellite. I'm pretty sure that maybe probably next year, it's our current offer will be a part of the ESA third-party commercial data. So last reference project that I would like to say is accessibility is very important. So 2019, we won our international tender to provide a Ethiopian Space Agency that it's a very new, young agency that they don't have access of the satellites. So we provide them a ground receiving station that can receive both optical and radar data, that they can direct task and also receive it in Ethiopia. Right now, they're using it as well for the military usage. So in this part of project, we also provide training with other industry partners to allow them to actually learn how to use it and how to better use satellite images for military, but also other applications for the country needs. Okay, yeah, here. So challenge. Even in this market, people have been using satellite image for years, for 20 or 30 years. But I think accessibility is critical to get accurate information, and also to be the first one to get information, because you cannot wait until tomorrow to take something that is critical for today. So submitted resolution is already available since a long time. So I think that's why important that I believe that I summarize quickly that maybe 3 highlights that I want to share with you today is, well, large scale daily coverage. Because today, this morning, we talk about a lot of radar, right? Radar, of course, like right now raining, it's not possible to use optical, so I'm not selling that thing that's optical. It cannot be used. But I would say, I will show a use case afterward, is that today the challenge of the optical data is because it's expensive. This morning we said, of course expensive, because when you want to cover a big area, you need to pass it again until you have no cloud. Because the swath is very limited, the tasking capacity is very limited for optical. So I will show a use case afterward that we have very big swath satellites that is very capable, which called Earth scanner, that I'll show afterward. So large scale daily coverage is important, is missing today. Near real time observation capability, every 15-minute interval of tasking area in the morning time. And the third one is, today, a lot of commercial offer is you can observe your targets in 1030 orbit, but it is sometimes difficult that you want to see something before, something after. You cannot really have it. So we have this also new satellite, we can offer this capacity. So the Earth scanner, it is a big baby. So today we have a lot of CubeSat satellites, less than 50 kilo, but this is, you can break the physics law. It is a very huge satellite, which is 1.1 ton. So it is the only satellite that can offer 50 centimeters of resolution, but with a swath of Earth Scanner 1 is 136 kilometers of swath, and Earth Scanner 2 is 150 kilometers swath. So you can see on the left one, this image is that the footprint of the satellite is operational right now, is that you can literally see the use case in a second, and the third slide is that you can literally cover the entire Israel or Lebanon or Qatar in one single image. Why it is important? Because in some place or in some situation, you can only have 1 or 2 days that you want to image the area, but you cannot do it because you need to, for a normal satellite, you maybe need to have 15 passes to cover this big area. So it's literally impossible. So it is quite new. The 2 satellites were launched 2020 and 2021, a few months ago. So I believe that timing is critical. How can you cover like this one? One pass is 150,000 kilometers square. So it is. I believe that it's very important to share with you what we can do. Just one quick example is that we do a case study actually in Qatar. That Qatar, Bahrain, we capture one image. You don't need to do any mosaicing. It's time saving, because when you want to have information, you need to process the entire Qatar. Maybe you take 2 days to do that. So it is also time saving in terms of very critical information analysis. So it is the actual image, how it looks like. It's just a cut with the one image. So on the right side, it's one single image, and we zoom in on different parts. So we can have we visit 4 days with the 2 satellites. It's how it looks like. Actually, it's 1.2 ton actually, the satellite himself. And capacity of data collection. So with the satellites today, imagine that you can image anywhere that's 45 times different AOI, 40 of the size, like a little bit more than Netherlands. It's because it's 40,000 kilometers square. You can capture 45 times similar size to Netherlands every day, tasking. And it is, I believe that it could be very interesting for some of the applications that we discussed this morning. So the 2 other points I summarized a bit earlier is that the timing, what time and when you can get the image to do change detection for some operation. So in order to have different time to capture your AOI, different time in the day, you need to have orbit. You do have satellite fly in different orbits time. So I put 2 together here. We're able to have every 15 minutes, but also in the early morning. So today you can have an image at 9 a.m., an hour before the 10:30 orbit with user orbits, but also we're collecting 4 times per day. It is a current situation. Next year, Q2, we're expecting 40 more satellites to be there. We're able to have 18 visits per day at submitted resolution. I'll quickly show just 2 use cases. Here is it is an image taken in Abu Dhabi airport in March 2021. You can see the first image. You see the plane arriving at 9:34. 15 minutes later, it's parked. Then 15 minutes later, the plane arrived. 5 minutes later, it's gone. You can see a bus just came, and then the second bus came. Another use case, border surveillance in Brazil and Paraguay. So it is the same, is that you can see day and night image would take 7 times to visit on the same day, on the same place. 5 in the morning, 2 in the night. So first one, second one, third one, fourth one, fifth one in the afternoon, and one night image in 9:50, and the last night image. So, and then we put the 2 together, day and night together. So this is my last slide. So I don't want to repeat it, but I believe that today the idea is early tasking, daily scan, and I believe that night date image could be very useful. That is not so used today. And I really hope that today we can have this roundtable to discuss what we can do, the use case together. Thank you so much.
Thank you very much, Kammy. And very interesting to see how technology is moving on and how much data can be created now. Our last panelist this afternoon is Jose Adriano Baptista. Again, has massive experience in the geospatial intelligence field. And he's now a senior advisor at European Space Imaging, where he guides the company's development. But he also spent a long time at the European Union Satellite Centre before then, running operations there. So, Adriano, floor is yours.
Okay, good afternoon all. This is my first conference after leaving an international organization and being on the other side as the one that was asking the companies to develop things and to be useful for the organization where I was. So I also feel a little bit like a rookie also in here. So my presentation today is not only to highlight some capabilities of the company that I'm representing now, but also talking a little bit in taking the topic of the session, how to enhance the situational awareness with the different sensors that we have at our disposal. So I will start, of course, with some information about European Space Imaging. Don't have satellites, but has a dedicated ground station and some agreements, contracts with providers of satellite imagery that will provide that capability and make this company as a leading provider for Europe and North of Africa, because it's the area of interest that European Space Imaging has at the moment, and has access to more than 25 orbiting satellites at the moment. So in addition to that, it's not only an image provider or a data provider, but it also has some partnerships with other geospatial entities in Europe, and not only, that would provide also other services. Of course, the main topic is satellite imagery. A lot of people mention satellite imagery. I was working on the field for more than 25 years. So it's always interesting to see what exists now, and European Space Imaging in this regards has access to all the Maxar constellation, which provide a good revisit, but in the future will provide much more persistent surveillance of the Earth with the new Legion constellation, with 6 satellites, with a resolution that is less than 30 centimeters, and with 15 daily collections from sun up to sundown. So the revisit time will increase a lot. However, it's not only data that we are talking about. And the topic is situational awareness. So I decided to go to the basics to see, so what is situational awareness? And basically the literature tells us that there are 3 levels, and they told me always that in presentations I should not mention more than 3 important things. So I gathered these 3 bullet points that for me are important and that are part of situational awareness, independently if it's for defense or for any other purpose. If I'm a pilot, and basically situational awareness is all the elements of the environment that help me to achieve a goal. And if I'm a pilot, probably the cockpit, the aircraft, the airport, the air traffic control system. These are the important elements that I need. However, there are a lot of things around this that I do not need to know and understand, so that we need a filter. So we mentioned a lot of the presentations today and yesterday on data, on collection. Yes, we collect more and more. Collection is increasing every day. We have more data. However, it's not only data. On the observation part of the situational awareness, what is important is not the capabilities on collection, for me, in my opinion, is to detect the anomalies, to know that something happened and I need to be alerted, and that could have an impact on the reaching my goal or my objective. Second level is how, with all this data and all these elements surrounding me, what is my understanding of what is going on, and what tools do I have to understand the complexity of the problem. And last but not least, how do I predict or project or the future with all these elements. So basically, and a lot of people mentioned this during yesterday and today, basically the problem is how we transform data into information, into knowledge, into wisdom or intelligence for the military, and into action. So all these steps, how we do that. So we have now a lot of data that we are already fusing, integrating, interacting. It's not only satellite imagery, we mix with other geospatial information, with vector data, with open source information even, or any other data that is correlated to that specific event. And I choose specifically one, this is not defense, but it's security, and it's something that is happening still in Spain, and where a lot of images were captured throughout the days with all the sensors that exist to know the magnitude or the extent of the lava in La Palma. And for that, use different sensors, and I just show examples of Satellogic, but also with GOI, with different perspectives, with different information that could be useful to understand the extent of the problem. However, on the observation part, we have to mix this with other information. It's imagery, it's vector data or maps, or even, and this was mentioned by Leendert also, other information that helps to assist to identify what is going on, whether it is optical or radar, but also with the help of other information like AIS or any other type of information that could provide a little bit of more understanding of what is going on. And then we have the tools. This is a small video. I do not have this music for the dramatic effect. But I will try to explain what is going on. It's basically, okay, you have this data, you need to interact. All the algorithms for AI, they are very interesting if you want to do at a mass scale. So if you detect something and you want to replicate 10,000 times, it's excellent. However, there are things that you need to address just for that time. And there are tools also that help the analyst to solve the issue, to understand what is going on. And all this is being developed by several companies around the world and are of value and are of interest to give this understanding of the complexity of the problem and how do I use that to achieve the objective. So we we listened during these 2 days about a lot of buzzwords about transparency, real-time knowledge, trust, tools, privacy, data, and all of those are important and all of those are interesting. But what is more important, what is in terms of situational awareness, that is the topic of today, is how all these tools and how all this together helps people reaching the goals and the objective. So my last slide is, how do we enhance that with Earth observation and geospatial data? Of course, there are no solutions, miracle solutions, but I put some notes addressing, again, the 3 points that I want to raise today on things that we probably need to work together in companies, with the governments, with the end users also. The increase of Earth observation sensors, it's now, it's happening. We saw Kammy with a lot of satellites, with a lot of data being available. So that is not a big issue. However, there is a need to have a better integration and complementarity of the sensors. And I think on that, we need to address also that particular point. On the understanding part, the new tools based mainly on artificial intelligence are also there. And they are being developed every single day, and they are promising and a lot of good results. Particularly on the computer vision side, and this gives such just examples of automatic detection, recognition of military equipment and so on, but also on the social media extraction that is becoming more and more important. One of the buzzwords is misinformation. It is important that what people have is information that you can rely, that you can trust, and that all these filters and all these tools that help to filter all the misinformation is important. However, we are very bad on predicting things. And I think on this is where the effort, and if we want to reach a better situational awareness, where we have to work more, is how we see the future, how we use all this to support the decision makers and also to support the action that will follow. Some people said that, okay, platforms, no, apps, yes. This morning, I put as a development of situational awareness platforms as a solution, but with robust predictive models, with something that is not biased, that we know for sure that we can trust, and that would provide the real time, also that we are mentioning all the time, capabilities that will support decision makers and others to intervene and to act if required. And with this, I conclude my presentation. Thank you so much.
Thank you very much indeed, Jose. And actually, I really like the way you sort of talked about those 3 levels. I think that's a really important point to go back to those basics for all of us. What I'd like is all our panelists, please, to come forward and sit in these what looks like condemned person chairs. And I think we've got some roving microphones. We'll just get those sorted out while you think of your questions. And we'll take your questions first. Yeah.
Oh, they need a microphone.
Yeah, we need the microphones, please. Just remind you about this microphone situation. It's for those that are online, not for us in this room. Right, so I'm looking around the room. We've had some real different perspectives here. We've had perspectives from, and we've had several presenters talk absolutely about what is the problem we are trying to solve. And we've had presenters talk about, well, here's something that adds into the solution space. And the key thing, as I said right at the beginning, is actually we've got to help people make decisions. We've got to help increasingly systems make decisions, or automated systems make decisions. So in a sense, we've got to try and push things higher up that, and I think Jose referred to it, this sort of knowledge pyramid, higher up that knowledge pyramid towards knowledge and towards wisdom and understanding. So with that, I'm looking around the room, trying not to babble on too long for someone who's going to ask a question. Anyone wish to ask a question of any of our presenters? Yes, please. You just take the microphone. Have we got a microphone, please?
Thanks. Maybe you can share one. Who had a question?
Okay, thank you. So it's been touched a couple of times in presentations, the use of artificial intelligence for situational awareness. What will be the biggest challenge for the panelists to use this and to gain this augmented situational awareness and helping the analysts? Thank you.
Okay, so perhaps I'll go to Jose first, actually.
In my view, it has to be more generic, not... The challenge is that you need to be very specific now to define what you're really looking at, to have tools based on artificial intelligence that really works. So for the challenge is how to be more generic with artificial intelligence tools. We cannot, if we have a challenge, and I work for 20 years on an organization that was supporting crisis. And we are also at TU, we are very, very bad predicting crisis. We never know when it will happen. So we never knew what would be the next day and what challenge we had. So how can we spend weeks training a model if we need to give the answer tomorrow? And the issue with artificial intelligence tools nowadays is that you need to train the model. You need to spend weeks. You need a huge amount of data to train the tool. And with that, if you have to wait for 2 weeks to, again, for the answer, left or right, it's useless. So the challenge is how to make it more generic, to make it used in more types of applications and not being so specific to the topic, to the area, to the day, to the type of sensor, and so on. Detached from that.
Yeah. Perhaps I'll just come on to Leendert next, because you talked about how you've been doing this in the maritime environment. Yeah.
Indeed, I think at the end of the day, it should be about supervised learning, if you really want to take the best out of artificial intelligence. But you also need to have domain knowledge, and that is quite often missing. You have people that are very good in developing algorithms and in applying artificial intelligence, but they do not know enough about the domain where it applies. It was very funny. We had a test a couple of years ago, also with a software company. It was a market leader in artificial intelligence. And they were looking at ship movements. And they came with a huge report, said, this is very interesting. We really have now established the pattern of the ship. But twice per year, this ship does something very strange and very old. You have to look into it. At the end of the day, this ship just went out for maintenance twice per year. And there was nothing old or strange going on. But it also illustrated the fact that you need both. You need to have the good, let's say, knowledge about developing algorithms and in the intelligence, but also the domain knowledge, so that what you see is really worthwhile to see, and you do not make, let's say, silly mistakes. That can easily happen.
Thank you. And Keith, from your perspective.
Yeah. So I really think it's an interesting question, because AI is mathematically based on how a person would think about an issue or a problem, right? And it's a statistical representation that can help you understand anomalies or when an anomaly happened. It is not the answer. And I love machine-assisted AI or ML, because I think that's where the real solutions are. And I would only point to, I'm kind of a chess buff, I'm no good at it. But I think it's amazing that a machine can beat a person every time, but a person and a machine can beat the machine every time. And I think there's a lot of knowledge to pick out of that. It's not about the machine solving the problem. It's about detecting an anomaly that's a statistical difference that you should be keenly aware of.
Do you want to come back on that? Anything you'd like to add, having asked the question?
No, I think those are really indeed the feedback that I receive as a company, also from our end users, is always about the human-machine teaming. So, and that's what will be the value in the future as well. So that's really, thank you for those answers.
And I think it also illustrates, and I think our panelists have touched on it, this importance of, bias can creep in. And we've got to watch how bias creeps in as we use machines. As we've said, it's AI is humans creating the sort of AI thinking. And in a sense, the biases that we've got to try and avoid, otherwise we won't get to that sort of level of understanding that we need that takes us into a different place. I'm looking around for other questions. Yeah, there's one at the back there, please.
Yeah, I had a question regarding tipping and queuing for the maritime environment. We saw today a few examples of very high resolution imagery, very pinpointing, and then with deep learning you can detect a lot of nice features and objects. Now, often it's important that you know first where should I point my satellite to. It's nice to look at your own naval bases or hostile bases, but if something happens in the middle, and my question is a bit, if we look at the maritime environment, the tipping of and queuing of lower resolution satellite imagery, is that an important step? Because costs play a huge factor in that. Are costs a constraint in actually being able to pinpoint where your high resolution data acquisition should take place?
Okay, well, I'll take Leendert's view first, but then I'd like Kammy, perhaps you can give a view as well from your perspective.
I think tip and queue can be of big interest in the maritime field because, and you say that it is expensive. I think the other way around. If you take a wide swath SAR image for initial monitoring of a large sea area, and then you detect something interesting, then you can thereafter order an optical image to be very precise and to look exactly what is the event or the situation to get more knowledge about this specific area. And you cannot do it the way around because optical images have, of course, only a small swath, and they're also extremely expensive. So to be cost effective, it's good to first start with a SAR image for wide area scanning, and then when you detect something of interest, then with optical, you try to gain more information with a higher resolution about what is going on in that specific area of interest.
Those wide swath images, there is a cost associated with that, but that's not a factor for your organization?
Well, I don't want to reveal any commercial information, but I think still that an optical image is 4 or 5 times more expensive than a SAR image. So in that sense, I think it's still worthwhile to start with a SAR image, and only then, when it is really of interest, to take out more money to buy an optical.
Sure. Yeah.
I think some companies actually
offer... Of course, Kammy gives great discounts, so you should not...
Yeah. And I think some of the sort of SAR companies and other companies out there offer a service that sort of covers that. But Kammy, because you're sort of providing data, how do you see this?
Yeah, actually, well, it's a very good question because we've been working with this maritime port since this year in March. So basically, you're right. Actually, most of the time we're using very high resolution, between 50 centimeters, 75 centimeters, because we need to see actually the ship, and in your presentation you see it as well. But I get your point is, of course, you said it's very true. If everything is not expensive, of course, why not you order it in a bigger quantity? But actually, interesting point is that I'm working on another project with another partners that we try to use low resolution satellites, 2-meter range, because we have actually 4 satellites that I didn't mention today. It has a 16-meter optical with a swath of 850 kilometers. So it is big enough. So we're working on a project that we're using the optical image first to see if we can scan the ocean, because that's 4 satellites. Basically, you scan it. When it is so big, you scan the sea to see, okay, where is more or less you want to detect the object. And we did some analysis of 2 meter is good enough. It's much, much, much cheaper than the sub-meter one. So you use that one to scan the most, because at the end, the maritime surveillance, you always know that the 10 top area that you wanted to monitor, right? So you first use this scanning. You can use 2 meter, you can use 60 meter, both much cheaper. And then you use very high resolution, some-meter resolution to complement it. So it is something that is not yet ready, the product I can say. We're working on it, but it is somehow the idea that how to get a compromise between high resolution, low resolution, the big area that you want to monitor, and the capacity.
And I think, Keith, I'd like to take Keith on that. And then I would actually like to come back to Leendert and just talk about other forms of tipping and queuing, because there are perhaps other data sources that can give us this as well.
So just quickly, I always think it's funny or odd when we only think of certain, tools in the toolbox. Because when the only tool I have is a hammer, the world looks like a nail, right? The whole imaging side of tipping and queuing, especially against a maritime problem, is probably 20 to 30% of the assets you would think about. To include commercial RF companies like Cleos or Hawkeye 360, to include other things like looking at insurance validation and AIS, et cetera. So I would look at that kind of problem set as a much broader problem set than just a SAR problem or an EO problem. It would be bigger.
Yeah, and I agree with you completely. And I just wonder, Linda, do you use other sources as well to help you with the sort of tipping and queuing perspective?
I think what was just mentioned about the frequency detection, I think it's a very interesting data source. Although what I understand, there are still problems with the data policy of the companies, and also about the reliability and really having it in operational settings. So I think it is a bit of early days to look at it. So we are very interested in seeing what those companies can provide. And I think it's a very interesting additional data source that we can use very well in the maritime domain. But I think they are operationally not mature yet to make it work. But we are there waiting to start to test whatever they can provide.
Yeah, and I would emphasize that hammering out those data use, getting at the licenses, getting proficient at exercising those muscles is key to getting forward on those problem sets.
Yeah. Okay, no, thank you. And does that help you with your...
Sure. Many thanks. Yeah, very interesting.
Brilliant. Looking around the room, anyone else got a question they'd like to ask? Have we got any online, by the way? And are there any online questions? No. No? Okay, good. At the back, Chris. It's Chris at the back. Yeah, please.
I was just going to build on that, right? I mean, at some point...
Chris, could you just use the microphone for the online folks? Thanks.
Sorry about that. Right, I mean, I think we've kind of gone full circle kind of back to Keith's presentation, right? I mean, at some point, there's a problem, and you need to come up with the encyclopedia of like all the data sources that you care about and to go after it. And, I think we've danced around the term persistence. Like a maritime domain awareness is kind of a classic case where the quest is to achieve persistent, understanding of where things are, and each phenomenology, each platform is different in what they contribute to that persistence. And it ends up being this giant rack and stack of multiple data sources, multiple phenomenologies that are all with different tempos and cadences. So, I mean, I guess I would ask the panel, but maybe start with Keith, because I think it was kind of the topic of his presentation. You end up with this problem. You need persistence, for whatever the mission. Forget about maritime domain awareness. It could be anything else. But it becomes like this big collaboration problem, not just an AI problem, because different people own different pieces of it. And I need like kind of this common way of looking at it. So, how do you see that challenge as we coalesce all these data sources around achieving almost getting to persistence?
Thank you, Chris, because that was excellent. I like to start back to the whole idea of situational awareness is I need to be aware of what's going on so I can kind of have a priori knowledge or an understanding when something's going left to center instead of center. So the idea that I can understand an anomaly or an outlier rapidly is key. In order to do that, I need the subject matter expertise of all those pieces. I mean, I've had a very specific use case with basically 5. By the way, the other group that was most interested in what we were doing was the reinsurance community, because they have to be able to understand the risk, not just associated with earthquakes, but climate change. I mean, this becomes a global problem, financially burdensome quickly. And so if you're not talking to or allowing the subject matter experts to participate in the awareness platform, you're losing perspective quick. both in terms of the data, because having data or images of structural problems in a building like we showed is important, but knowing who took the picture and what their background is as critical. So, authentication, attribution, and auditability of the content within the platform is critical within the platform. I got to know who said was it a fireman or was it a structural engineer that said this is a load-bearing beam, right? That's a big difference. So I would just say that, and then it becomes critical the longer or further that goes.
Okay, and perhaps Jose, you can offer a view on that as well, please.
There is one thing that I do not fully agree is the fact that persistent surveillance is mainly for maritime fields. It's needed everywhere in every single situation. It's easier for the maritime field because it's less complex. So the problem is the same. It's much more complex and much more difficult to achieve persistent surveillance over complex areas.
I would agree, and I would say space situational awareness is a great example where it's all about persistence.
Exactly. And that was the point that I
And I
wanted.
think there are a lot more data sources come into, and I wanted to come on to in a second the urban environment, which is actually one of the most complex environments to get a situational understanding on, especially if you're looking at it from a defence perspective. But I wonder whether, Kammy, you want to say anything on Chris's question?
Yeah, well, I think, there are lots of data sources available today. There are AI, there are people working together. I believe that, from an industry point of view, that's I believe right now, it's not because we don't have data. It's not because we don't know how to do it. It's all about the business model, how we work together. And we talk about the courses, we talk about the technical difficulties. So for me, I believe that the next step to go through that is we need to build a use case together between the industry and the user. And what we need is really being addressed. So I believe that this type of, in Europe we have it. Sometimes we work with some of the partner, but also with the commission, with the agency. So I believe that this could probably be changed in coming years because we're not missing input. It's just how can we put all input together to put the output at the end to address the end user requirement like. Leendert next to me, we talk because we want to know what the product that is expecting that can address this issue, I can say somehow.
Just to add, in a format that everybody can understand. And this morning, we listened to our military Dutch colleague saying that they are not experts using that information. So we have to put also the information at the hands of the end user that probably is not an expert, and it's someone that is on the field and needs to act and interact with the data in a simple and effective way.
I would slightly modify, at least from my opinion. He was not the end user. He was supporting an end user.
He was supporting the end user.
Right.
But he mentioned the fact that
Right.
the end user that is on the field is
But
not
that
an
person
expert.
is not a geospatial expert, and that person needs to be able to consume information in a way that they can support then their activities. So it's complicated.
And I think in the military environment, there's lots of people with the experience in here. You're doing all of this under enormous pressure.
Yeah.
Enormous pressure. And there is now far too much information. It's never quite the stuff you need. And these are really difficult circumstances we're talking about.
And if I may just to add all this, and there is another element that we need to consider is the communication, how this is transmitted. And again, we are talking about platforms, apps, tools that may not work on the area where we work. So we have also to see how the information is transmitted to the people that really need it, and that not all the time has access to new technologies.
Okay. Now, if I can, I'm just going to say, has anyone else got a question? Okay, because I'd just like to take us into that urban environment. We've looked at the maritime. Keith touched on urban with San Francisco and that particular use case. But I just want to think generally, most people will be living in cities, and Chris could tell us what percentage, 75% by 2050 or whatever. And that's the area we really need to have a situational understanding of, and it's incredibly difficult. And I know, it's not necessarily about Earth observation, that's part of the picture. But how do you see us gaining, from your perspectives, that increased situational understanding in an urban environment, in that environment that's largely indoors rather, can be underground, can be outside? How do we get that understanding for our operators in that environment?
You have to start to understand what data sets are particularly important to what questions. If it's about population satisfaction with the local government or dissatisfaction, you can start to look at any kind of indicators from economic growth or economic stifling to price of bread in neighborhoods to gas to who has fresh water or not fresh water, where are the gas lines, where are facilities or support infrastructure helping people versus being slow to respond or not assisting in communities. You can start looking at building codes, et cetera. I mean, there's a lot of that. That's why we kind of built this, like that, at least how we were looking at it is whoever's trying to answer question X needs to be able to pull that content in. What we're trying to make sure is clear is that there's a whole bunch of other people in the platform. It's a multi-user environment where you're making observations and annotations about that environment all the time. You need to know who's making an observation, but like I said, it's critical to know what that person's background is, what problems they were trying to solve, and how what the audibility and attribution to that data is.
Okay, no, thank you. I'm going to take everyone's answers. Who would like to go next? Jose.
Okay, my view is that we should, in addition to model the buildings and the road network and all the infrastructure, we need to somehow model the real life and how people interact with objects. And it's the only way that you can achieve that situational awareness and improve is to model the real life and integrate it into the geospatial domain. And we had an excellent example yesterday when we showed the John Hopkins portal with diseases and COVID, and we represented it in the real world. Your example today also of the fire in a city and where the fires occur, this is real life information that is integrated into the object, and that will give us more elements to provide solutions or provide answers to the questions. And I think this is the big challenge.
Okay, and I know, Leendert, you've got a sort of maritime background, but anything you would like to...
What we have in common, actually, also what Keith is doing is looking at the pattern of life, but then of the fires and where they occur. So you look at some systematic occurrences that you try to map in order to be better prepared for the next time. Whether you do that in the maritime domain or in the urban domain, it doesn't matter.
And Kammy?
Yeah, of the urban. So in one of my slides, actually, we do this pilot project by using the day and night image over a city. Actually, it was border between Paraguay and Brazil. So it is in a city. And that's interesting because for that urban, you can address the more in a national security issue because you surveil the border. So even in the city, you can have things that should not be happen in the border, of course. So I believe that's at the end, when we use satellites, we need to think about why we use it. It is because current technology cannot use it, because maybe the border is too big. At the end, you cannot just always send people over there to check it. You can only see it from very discreetly from the sky. That's one solution. So for me, how satellite image can address it, we need to think about what is missing today, why we need it, what the current situation is, what problem we want to address. So one of the urban, more related to the national security, I can say. The other topic is, I didn't mention, but I think we are playing around with the night image today because I have several use cases that during the COVID, we did image some cities that is to have actually monitoring because some cities closed. You're not supposed to go out, right, during the COVID lockdown. So we did some use case even in China, in US, and Europe. You take the image over the city where you can literally see there's no light or there's some place. So it is really urban monitoring by night image is not so useful to use it. And we do use it also as well when the urban planning is that when you have the power light cut off, basically you want to see it every day or even an hour after. Is the power light is already recovered or not through the night image from space? Because you cannot always send people to do your own survey analysis.
And I think we're going to close this now, but I just want to add my own example here. And it goes back to my original sergeant advising a brigadier general. When they got into, this was Iraq, when they got into Basra, Actually, the biggest problem was keeping the electricity supply going to the population. By far the biggest problem. And actually if they had had knowledge of how much fuel there was at each of the power stations, then actually perhaps the logistic effort could have been geared before the war to make sure you could keep the power going. And of course, actually you can now get ideas of how much fuel there is in different places, et cetera, et cetera. So it's that bringing together of many different information sets. But you've got to know the problem. You've got to predict what the problem is. You've got to really understand that space that you're going to be operating in to get the answers in the right time zones. What I'd like to do, or gas, whatever it is, yeah. But what I'd like to do is thank our panelists for actually a very enlightening afternoon, and thank you very much for the interactive discussion at the end there, and thank you for asking those questions. So Leendert, Keith, Kammy, and Jose, thank you very much indeed for your time this afternoon. Round of applause.